Hello, how you doing? My name is Scott. I'm here from Loadbalancer, and we are really pleased to have an incredible speaker joining us from one of our favourite companies on the planet, Cloudian. I'm not going to steal your thunder here, Neil. I'm going to let you jump and introduce yourself, but we're going to have a bit of a chat around object storage. That's definitely the more interesting, fun bit of our conversation. And what I'd like to do is get to a point later on where we're talking a little bit about why object storage is brilliant, how it's used, and how and where we see that happening today in businesses, and a little bit about why load balancing is important around that. But maybe you could introduce yourself, Neil.
Sure. Hi. Excuse me. It's very early. So Neil Stobart. I'm VP of System Engineering. The global team at Cloudian. So we look after the pre-sales function, the installation guys, the training aspect. So anything that's kind of technical conversation with customers or partners, going out there, that I kind of look after that team. I've been in the storage industry for quite a long time now. I can't even remember quite how long it is. I think 96 I started in IT, so what's that, for 28 years, 26 years? Not very good at maths either. Um, yeah, so it's obviously we've been working together for a little while, and very pleased to be here.
Super. Well, it's great to have you here, James. You've joined us as well today.
Yeah, so James Loveday, Neil and I have been talking for, I don't know, 5 years or so now. So we're well acquainted. Yeah, I'm one of the sales specialists here with a strong focus on storage. So yeah, glad to be here.
Well, brilliant. Thank you, guys. And it's great to have you both here because, as you say, I know you guys have worked extremely closely. And obviously, our relationship with Cloudian is growing, and we seem to really complement each other's products. And I think there's a lot of benefit to what we do here at Load Balancer, but a huge amount of equal benefit the other way as well. So we see some brilliant alignment within object storage. But so I guess really the point of today's chat and what I'd love to hear from you, Neil, really is you are the specialists in object storage, and you have that really found grounding in understanding the technology and having the ability to convey the benefits of it and why it exists and where it's come from, probably far better than we can. So I wondered if you might take a few minutes just to tell us a little bit around what is object storage and why it exists and maybe where it came from.
Yeah, sure. So I mean, it's a technology that's been around for quite a while now. I mean, I used to work at Hitachi Data Systems in the around about 2005, and they actually had a product then. EMC had a product out, even before then. I think the first one was EMC Centera. And really, it came to market. I think at the time they were trying to look at more sort of the protection of data in terms of the immutability, the worm aspect of it. The main organizations that were actually deploying that kind of technology 20 years ago really were using it for immutability. The challenge with I think at that time, the reason why, we're not, we weren't talking about object storage 20 years ago, I think it was kind of two key reasons. One, every object store that was built had its own proprietary API. So if you had a backup application, for example, that wanted to back up to object storage, it would have to, code a proprietary integration point with every different vendor. So it's very different to things like NFS, CIFS, and SCSI, traditional object storage protocols and tech connectivities. The API, which basically is it's a programming interface, it's very different. So you do have to do that coding. So as more and more entries into the object storage market came along, there's just more of these APIs, and there was some industry initiatives to try and standardize, but that never really came off. And it wasn't until really Amazon, AWS, they came to market with their S3 object storage service that then sort of changed the game. And following that train of thought, what's happened is that the S3 API has become the standard for cloud storage, object storage, whatever you want to call it. So I think that's really helped drive the popularity of it today. The other key thing rolling back to 20 years ago was that actually there just wasn't that much data. So, at Hitachi, we were selling block and file, standard block and file solutions. The drives were around about, I think the biggest drive, 1 terabyte. The 1 terabyte SATA drive had just come to market. Now we're looking at 20 terabytes are on the market, and you talk to the disk drive vendors, and I think they're talking about 50 terabytes in the next 10 years. So the amount of data now that's being created, I mean, we're now in the zettabyte era. I think it was about 2013. I think somebody had sort of looked at the amount of digital data that had been created, and at 2013, that was the sort of the turning point. The amount of digital data was, 2013 was covering every amount of data that had ever been created by humankind, that had been recorded in books, film, or, all different types of media. And then from 2013, I think we're now like 3 or 4. It's a ridiculous exponential growth that now we've got so much more data than was ever created before 2013. So it was like that, crossing that Rubicon a little bit. So at the time, I think object storage, it is a platform that's designed for large scale data management. 20 years ago, it just wasn't quite there. So we're all now, and every individual is a video creator, is a photographer, is a music maker, and this has been driving data growth immensely, along with the introduction of IoT devices, machines that are creating logs and analysis and data points. And the thing with machine data is it's just always on, it's just churning out data constantly. Whereas in the past, data created by humans, it takes time. It takes time to write a Word document or create a PowerPoint presentation. So, machines are just, have just taken over in terms of data creation.
I guess that's what's fueling that sort of exponential growth, isn't it? Is the fact that as you say, we had a limited number of human beings that were creating something. Now we've got a stupid amount of bots, systems, applications, log files. It's just that exponential growth, and I guess there's probably no curve to it's not likely to calm down. That's only going to get worse. I mean, I'm guessing your predictions are that continues to exponentially grow.
Yeah, I think it's kind of like I think there is a name, but the Moore's law around processing, it's kind of like that now with data creation, because the thing is now, I mean, we about 5 or 6 years ago, we were working with a vendor that made smoke alarms.
Right.
A smoke alarm that you put on, the top. Now you think about a large office building or somewhere like an airport, how many of those devices there are. I mean, there's tons, and those devices now aren't just dumb detect smoke and bleep. The Wi-Fi connected, and they're sending health messages, they're sending warnings. So you think about just how many smoke alarms there are, and now as we're getting into the connected car era and the autonomy around cars, we've been talking to one of the big car manufacturers, and they reckon they'll generate 1 exabyte of data a year. Now, I don't know, rough sums, for an exabyte of data to store that, it's going to be, you're looking at about $300 or $400 million as a.
That's crazy, isn't it?
From log files, essentially, which is text.
Yeah, of course. Yeah.
I feel as if I've made the right decision on what career to get into.
Yeah, exactly.
Poised for growth.
Well, and I think we feel mutual, because obviously one of the great things about your stuff is that I'm going to argue that we bring some benefit. But before we get there, I guess one of the other points to talk about is you've given some great examples of why we would use that object storage, solution around scaling data, the absolute scale of it, and how object storage is so much better aligned for that scale and growth requirement than traditional NAS and scale out NAS and things like that as an alternative. Where's most of the business today? Is it? I mean, obviously in my world, from what I see, there's obviously a lot of backup. People think object storage and immediately think backup, and I guess a lot of the options around kind of log files and grabbing data and API integrations and ditching large machine learning data lakes that can then be accessed by some sort of AI platform. And I guess all this stuff is the exciting stuff we read about in online and in the papers. And is much of that happening? Is a lot of it sort of traditional backup today, or are we seeing this sort of? Have we hit that point where data lakes and AI are becoming more mainstream around object storage?
I think mainstream, that's an interesting word, but yeah, we're seeing those workloads,
Yeah,
absolutely.
yeah,
It's kind of interesting because when I joined, I mean, I've been in Cloudian for 7 years, and really that was at the beginning of the sort of the new wave of object storage interest, let's say. I think where, the technology actually has a place in the market now, that it didn't 20 years ago.
yeah,
And I think there is a bunch of differentiations about object storage. One is the purest scale that you can grow to. So we can, build a single storage platform beyond, 2 or 3 exabytes. That is, you cannot do that with other types of storage architecture. You can't do that with traditional scale up architectures. And if you look at all of the storage vendors, they all have some sort of scale out object type storage solution. So I think everybody is seeing this, and it is the way forward. I now look at storage in terms of there's kind of two needs. You either need something that's transactional, very small operations that need to happen very quickly and very, very low latency, or you're dealing with unstructured data, which are files, can be small, can be large. And I think that's where now the delineation is coming. You look at the workload, what's it generating, really dictates what type of storage you should use, and then obviously how much you're going to create. So scale is one of the big things about object storage. The use of an API rather than a kind of dumb connectivity protocol like SMB or NFS or Fiber Channel or whatever. Because ultimately they just are using SCSI command sets, and that really boils down to you can read data, you can write data. It's about it.
Yeah.
yeah,
Metadata on a file system is relatively limited. It's limited to system, your
yeah,
file level metadata. So what's the file name, how big it is, when was it created, last accessed, all that kind of good stuff, which is useful if you use it. With the API and with metadata, with object storage, it's kind of how we manage data access. It's done by the metadata. So metadata basically is they always reference, if you take your coat, in the bar and you put it in the cloakroom and you get a ticket, the ticket kind of describes where it is on the rack, and it could be a big room, right, if it's a big event. So basically metadata is what the customer presents to say, I want my data back. And then if we have a very large distributed database that is very, very scalable as well. And that is kind of the secret sauce behind what we do at Cloudian, to get that ultra scalable aspect of the solution. But within the metadata, we don't just do system metadata. You can also create your own user metadata. So if I'm storing a JPEG of my cat, I can actually include that it's the cat in the garden, with my son, with my daughter. I can actually put all that information in the metadata. So later on, I can do a much more advanced search rather than saying, show me all my pictures from a certain date. Just return pictures of with my cat and my son and my daughter in our garden. So you can get very complex queries built into that. So that sort of adds more intelligence to the data. So you've got the API, you've got your metadata, and you've got your scale. We also bring in the concept of scaling, not just in terms of the amount of capacity, but also across different locations and regions. So we can create a data center, a cluster in a data center, let's say in the UK, and we have customers that do this. And I'll give you an example. A customer, I think it's about a 20 petabyte solution, and they have a data center in London. They have one on the east coast of the US and west coast of the US, and it's actually a single cluster with a single namespace. So you can lose a data center and still the service will still be running, but now you're getting rediverted to get the data from the other sites.
yeah,
So we've got some very strong data protection and replication technology that kind of is syncing the data up invisibly to the end user. So in the past, if you wanted to sync up all your day's work and send it across to another region, it was basically a batch process. You do that at the end of the night, and then you'd send everything across. At the other side, they'd then work on it and do the reverse, coming back. Difficult, time consuming, prone to error. Now it just happens.
Well, I think you hit one of the key points there, which was that certainly around the API bit, just to talk to that bit a second. I guess you're right, actually, thinking about it. Those sort of legacy file systems, you're right. We could save a document. We could save what we knew as a file or a folder, I guess, and stick it on a NTFS partition or an XT partition, whatever we like. But actually, what we're saying then is by using an API, our abilities or our options and our possibilities of what we can do with storage are only limited by the imagination of a developer, or a team of people that are coming up with an application, and how they interact with it may be something that we haven't quite yet conceived, but they could be thinking about some crazy way of using that API to move files and data. And I guess the point is, we don't think about files here at Object Storage. We're talking about binary blobs potentially, aren't we? Or moving data. We're not talking about our Word document. We're talking about some sort of binary blob of data, and that could be anything, right?
It is a Word document or a log file, or but it can be more than that. It could be a single email, for example. That classified as an object. It just depends on how you write the data down.
Yeah.
But just going back to that point, I mean, the S3 API has something like 450 different verbs. Wow. That an application developer can take and think, what do I want to do with my data here? So once I've written it, what then do I want to do afterwards? Do I want to change it? Do I want to move it? Do I want to protect it? And now you've got the ability to put data management in the control of your application, whereas in the past, with your regular sort of storage arrays, if you wanted to use replication, that storage array had to have replication. When it was making a second copy to a second site, often the application wouldn't know about that. It would only know the first one, and then it would be up to the storage array and some sort of manual process to
work it out.
To tell the application, hey, now the data's over here.
Yeah. It's not. I think that's why I think Amazon have really set the standard, because it's been born out of necessity, right? They've had to come up with these different scenarios because of the sheer scale of data, and I think that's why they've really set the standard, because they're forced to make these decisions and they're developing it into the S3 API. That's
and I guess the point from Cloudian's perspective, and it's a common thing across all of the object storage vendors, is to support S3 as an API. So what was the reasoning behind not creating your own one? I mean, basically, I assume because we want standardization, right, across the industry. I mean, that would be the sensible thing, right?
Well, it was a gamble for us because I think we started developing about 2011, and at that time, AWS had just were just starting. They weren't the ubiquitous company that they are today. Yeah. So at the time, there was another API called the Swift API. Right. The Storage Networking Industry Association were trying to get behind something called CDMI, which was, they were trying to push that as an open standard. Swift came out of the OpenStack development community. But for a while there, Swift was and S3 were kind of neck and neck. Mm-hmm. And, we did have a competitor. They were actually acquired by another company, but they were called Swift Stack. And they'd, guess by the name what they were doing. They were kind of focused on Swift. So our founders had decided that S3 is the future. Yeah. And they gambled. They gambled on it, and or made an incredibly smart decision.
Exactly.
I'll leave that up to you to decide. But I think it was the right decision, because now if you look at all of the data management applications, they support S3. So there's still others around as well, right? You've got Azure, from Microsoft, then they have like their Azure stack. Yeah. Google's very, very similar to S3. There's a lot of compatibility similarities, but again, it's slightly different. But even some of the bigger clouds like Oracle and IBM, all what they're doing, they've all got behind S3. So one of the appeals, we deal with a lot of service providers who want to offer storage as a service, just like Amazon. Yeah. So it's easy for them to choose to work with us because we have, fantastic scale, but we also have a very, very good implementation of the S3 API. Probably, I would say it's the best on the market. Yes. Because what we do is we decided not to go proprietary route and put it in that. It's almost that is our proprietary. We're just going to follow what Amazon do, we're going to emulate exactly what they do. So if an application says it supports AWS S3, we can sort of claim compatibility as well. And generally that's the case. It's very unusual that there's an application that doesn't work. I mean, for a little while we ran an S3 guarantee that, we guarantee that we will work with your application. And I think we got bored of that as a promotion after a few years, but still sort of around that we are quite bullish in terms of we think it will work. But that for me is the major benefit in a way for application developers, is they can move up the stack into their application exactly how, know exactly where the data is, exactly that they can issue commands from the application to say, do this, do that. And now we're seeing data sitting in an S3 format that can be part of an end-to-end workflow where, the data might be ingested by NFS, but now that it's in an S3 format, you can have, and especially in the Amazon ecosphere, you've got little Lambda functions that can do things on the data in place in situ, or give you a view of, I can look at a data object through a Lambda function, and it might look entirely different to how another set of users are looking at it through another Lambda function. So you get different lenses on your data sets. And just to go back to your question or your point about the backup side, we stumbled on backup as a use case.
Right.
Big storage. We were out there saying it's super intelligent storage. It's great for analysts, analytical use cases, and of course that is it was early days for a lot of that technology. So we were struggling to find those use cases, but we were getting a bit worried. And then all of a sudden, backup came along. We were just like, wow, that actually object storage is fantastic for backup, and especially when you put in the worm piece as well with the S3 object lock. I mean, that's happy days, because now, I mean, we work a lot with Veeam because they have really good integration with object lock, and now you can just be guaranteed that your data is immutable, your backup data. So you've always got a copy that you can go back to regardless of any hack or attack. But yeah, so
risk to any
that's
business.
been useful. That's been useful to kind of keep going, but it's not particularly interesting to talk about.
I think it is when you think about the risk to businesses, though, from ransomware. Every business is at risk, either fiscally or otherwise, from having their data locked and being unable to access it. But if you look at industry verticals like healthcare, it sounds extreme, but you're potentially affecting patient outcomes. If some of that critical data, that operational data, and just public perception, the NHS have been hacked. They've been, it's been publicly publicized that they've been attacked by ransomware. So for those kinds of organizations, it's a little bit more at stake than perhaps the enterprise, where it's more fiscal, it's more operational.
Well, I guess that's also showing the maturity of object storage, because as a techie, I'm sitting here getting excited about machine learning, big data, AI, all those sorts of things. But actually, as a more commercially orientated person, you're thinking about those sort of C-level conversations about, well, actually, it can be that, object storage really exciting, fun, techies love it for this, and this. But you're thinking about it from a commercial security, scalability, resilience, and things like that.
What happens after you get it? How can you use that to your advantage, or as a means of protecting your business, your organization?
Yeah, absolutely. So
at the time, the first conversation with the customers around ransomware protection. That's why there's a lot of people talking to us about that. So we get in there, we sort the use case out. We're ticking along, running very nicely, and then we're then talking to customers about, well, what other kind of data have you got? Do you want to sort of get more out of it? And then we start to see more workloads coming on. So in a way, backup is the door opener, because everybody understands backup. Not everybody understands what you can get out of the data sets that you have, because there is an element of you got to work out what you want to start with, and then how you're going to extract that out, and that involves other technologies as well. But that's something that, again, with the evolution or the revolution, I suppose, of what Amazon are doing, they are adding in more and more functionality. So we're now working on a project where we can bring that Amazon Lambda functionality And they have there's an S3 API called S3 Select, where you can do SQL queries on the storage platform on kind of like text data. So in your application, you could say, I've written all these log files. Now go and look for these strings of data. Okay, that log file has got the string of data in. Is there an alert there that we want to put out? And this is all just a function of the storage platform.
Yeah.
And that's really powerful. It's that data is driving business decisions, right? So the more you can do with it, the more you can interrogate it.
So I guess that the piece where we come into this conversation is around things like high availability, so and concern about the accessibility to the data. What happens if a Cloudian backend node fails? We talked earlier about sort of replication between different data centers that could be on different continents, and so I guess in my mind as a technical person here at Load Balancer, and I think about the things that we bring towards object storage and how I feel like we benefit that product. That is around things that, like global server load balancing, is something that we are able to offer within our load balancing equipment, where we can fail entire data centers to other data centers, even though the Cloudian backend nodes are replicating across the two data centers. We can say, look, your user is sat in Europe, and the best data center for that user to access the best Cloudian object storage platform is in London, let's say. And they're going to dynamically, we call that topology weighted, so we're based on the topology of a client. We're going to end up hitting the data center in London. But if the client's in America, we wanted to go to the New York data center. We have that ability to control that. And I guess the other bits and pieces that are the very obvious things about load balancing, health checking back-end Cloudian nodes, identifying if there's a hardware failure or something's gone wrong, rather than having traffic going to that failing node, which would continue to happen without something like a load balancer.
We DNS round robin,
exactly
for example.
that. So you would end up, let's say you had 10 back-end Cloudian or object storage nodes, then 1 in every 10 requests is going to fail without the requirement to have that load balancer sat in front of it. Because as soon as we can see that a node's down, we can stop that connection and pass the traffic through. So I'm aware that nowadays it's very rare that an object storage provider puts out an object storage platform without sort of using a load balancer in front of it, Neil. Is that fair? Yeah. So really the reason behind that is to guarantee that ability, right?
Look at your, what's the typical use case for a load balancer? It's usually where, you need to distribute across multiple servers, and you kind of want, those servers to, you want to simplify that to the end user interaction. You want there to be a single IP address, or you want there to be, one name that you're writing to, or, and in the background, there's lots of clever things going on. We're exactly the same. You could name any application that you can distribute, high performance computing or distributed databases. It's essentially, we are a cluster, a Linux cluster. Database, really, big scale out distributed database that can go across 4,000 nodes in a single cluster.
Yeah.
So, it just so happens that the application that we're delivering is data management, it's data storage.
Yeah.
So there's no difference between doing a data storage platform and some sort of compute cluster. And then the need for load balancing is still absolutely there. And we obviously, within our software, within our solution, we've got the capability and the functionality to kind of distribute the data across all the nodes and keep it balanced and do all of the housekeeping, all that sort of stuff. But I think when it comes to accessing it, that's where the load balancer comes into its own.
Yeah,
that's it. It's making those decisions, isn't it? It's that intelligent decision.
It's based on more information of the infrastructure that we're not actually seeing.
Yeah, it's about user access, I think, from a load balancer standpoint, because you're doing a really good job of protecting and distributing that data. But it's about how do we ensure that those users, those client applications, always have access to it. A simple case in point is backup. We talked about immutability and protecting an organization's data. If you're happily backing up in your data center and you have a failure event and the load balancer detects that backup will continue being ingested into the storage somewhere else. So it's impacting recovery point objective, recovery time objective, and making sure that data is secure. Without that, you potentially got a period in time where your data's at risk. So that's where the load balancer is helping with the access part, I think.
There's two really other two tiny little technical things that we've been talking about, and things like IP6 to IP4 translation. You know, suddenly we've got an ability for the load balancer to sit there on the internet talking IP6, but talking to a legacy system at IP4, you know, or a system at the back end, that the switching and the infrastructure, I think, that's still running IP4. Yeah, I thought he was. Yeah, absolutely. That's fine. So there's one thing, and also other little subtleties, like, let's say you've got to do a recovery and you want to get that recovery. You want to do it. You've used your object storage platform for backup, and now you want to pull your data back, but you want to do it very, very quickly. And there are technologies in our world, you know, around layer 4 load balancing, where we can pull data out of the back-end object storage environment without going through the load balancer, which means that actually, whilst you can have a backup that's with your ingress traffic being load balanced out to back-end nodes, we could also do at the point of backup. So I need a really, really fast backup. I need a really, really fast RTO. I've told my boss that we can recover all of our data in 6 hours, you know, and I know that if I actually try to pull it out, we might struggle to do that. Well, you could have a really fast system with load balancer where it becomes out of line, but is able to pull all of the traffic off of all of the back-end nodes all at the same time, potentially. Do you know what I mean? And actually get the entire scale of your Cloudian back-end. So there's a lot of, I guess the point is, a lot of benefits to both sides of this relationship, isn't there? You know, in terms of what we can offer to object storage and what object storage can offer to load balancing as well. So it's a very natural relationship. So
I think it's because I think you bring a simplicity to the solution. Look, when you've got a cluster, you know, it's a large scale out cluster, the importance of the networking is just magnified. You're talking about kind of traditional storage networks like fiber channel or even dedicated iSCSI. Typically, people think about them and carve them off, and it's all segregated and it's all very, very controlled, and actually pretty inflexible, right? Because it is almost like one-to-one direct mappings to clients and servers.
yeah,
Now we're in the world of everything's being networked over the internet. You know, and that was another advantage of the S3 API, is that it's based upon HTTP and HTTPS, so it's routable, it's designed, it's a data storage protocol designed to be used across the internet. And of course, you know, just what we've seen over the last couple of years with the pandemic and everyone working from home now, all of a sudden your file server sitting on your corporate network, it's not geared up for now, you know, remote data, you know, file collaboration. So again, this is another benefit. It's almost like things keep happening that just scream more and more object storage.
I think you're in the right world, definitely. I think you're absolutely in the right world, and that's probably the right word to leave it on, isn't it? More and more things are happening in the world that scream object storage, which is absolutely the best way to end the conversation.
Great place to finish.
Exactly that. Neil, thanks so much for all your time. Thank you. I know how much of a busy man you are, so really appreciate your time. It's lovely speaking to you. We will continue speaking to you going forward, and we look forward to carrying on. Take care.